Hello everyone. Today we are going to start our 10th chapter, that is Heron's formula, first class. This is our first class of chapter 10. In this class we are mainly study about the area of a triangle by using the Heron's formula, as well as a triangle, its basic properties and some other things including history of the Heron's formula. So let's get start this chapter. Okay. Introduction. First of all, introduction, how this formula arises and how this formula make. This is a very important question to know about it. So the history of the Heron's formula tell us that the Heron was the name of a scientist, was born in Alexandria in Egypt in AD 10. AD is the time after death of Christ. He worked, this is a history of Heron's scientist. So Heron was born in Alexandria in Egypt in AD 10. He worked on applied mathematics. He worked on applied mathematics and wrote 3 books on mensuration. There is a chapter which you are going to study in class 10, that is mensuration, which mainly related about the areas of different shape and size things like triangle, quadrilateral, parallelogram, rhombus, many more, kite, rectangle, square, different sizes, different sides, that all area includes in the book written by Heron, that is mensuration. After that, he derived the famous Heron's formula for finding the area of a triangle. What you are learned? We have learned that he has written the 3 books which are known as mensuration, as well as he only derived the formula, Heron's formula, which is useful to find the area of a triangle. For what area of a triangle or which type of triangle is used while finding the Heron's formula. So now, what is Heron's formula? So let's get start. Our main topic, that is Heron's formula, is this. Heron's formula. So first you have to understand what is the formula, then after we are going to practice some questions related to this formula which help you to easily understand this formula. Okay, now let's make a triangle. This is a triangle. We have named this triangle as ABC and the side name as A side, this is B side and this is C side. Means this is the length of the side which are mentioned in a small alphabetical, while the corners of the triangle is mentioned in the above, means capital alphabets. So let ABC, let A, B, C, which one is small alphabetical ABC, are the sides of the whose sides are given. These are the sides of the triangle. The semi-perimeter S is equals to, means first of all you have to know what is perimeter. So perimeter is the sum of all the sides. If I am simply asking you what is perimeter, which is of anything, means of any object, when I ask you a perimeter, it's just a sum of all the sides of it. Have you got what? It is a sum of all the sides. And here what he asking? He asking a semi-perimeter. Semi is used when we going to half of something. Here we have to doing a half of perimeter. So the semi-perimeter is A plus B plus C by 2, that is perimeter upon 2. This is a semi-perimeter. After that, so the area of a triangle then make, so the our formula arises, area of a triangle, we have named it as a symbol that is written in the form of this, ABC equal to under root S, that is semi-perimeter, S minus A, S minus B and S minus C. Have you understand it? What? First you have to find the semi-perimeter, that is the half of actual perimeter. Perimeter is the sum of all the sides. After that you have to find the area of a triangle, that is under root of S, that is semi-perimeter, bracket S minus A, S minus B and S minus C. I hope you understand the formula. After that, here are some other formulas of also finding the area of a triangle, but this formula is mainly used for finding the area which have an unequal sides, means when all the sides of the triangle are unequal, means there is a condition, that is A equal to B equal to C. Have you understand? After that there are also some other formulas. When first, if base and height, if base and height of a triangle are given, then what is the formula? Then the area of a triangle ABC is equals to half base into height. What is the formula? If the base and the height of a triangle is given, then the formula of area of triangle is half base into height. Next, second, for an equilateral triangle, for an equilateral triangle. So for an equilateral triangle, so first you have to know what is an equilateral triangle. As you have studied in your previous class, so there is no problem, I am actually going to tell you here only. So what is an equilateral triangle? A triangle whose all sides and as well as all angles are equal. Do you get it? What equilateral triangle is? A triangle which is having all the sides as well as all the angles are equal. So, if an equilateral triangle is given, then the area of a formula means area of a triangle is equals to root 3 by 4a square, where a is the side of equilateral triangle. Have you understand it? What if the base and the height of the triangle is given, then the formula is half base into height. And if there is an equilateral triangle is given, then what is an equilateral triangle? A triangle having all the sides and all the angles are equal. Then the area is root 3 by 4 a square, where a is the side of the equilateral triangle. Then if we are going to find where the height of the equilateral triangle, the first of all you have to do some work, like you have to draw the equilateral triangle. Here A, B, C, there is height, all side is equal, this is an perpendicular, this is A, this is A, if a perpendicular, then this become bisect by A by 2 and A by 2. Okay. Now you have to find this the height of the triangle, that is, so if we are going to put Pythagoras theorem, which theorem? By Pythagoras theorem. I already told you about the Pythagoras theorem. If you have forgotten, no problem, I am going to tell here only. By Pythagoras theorem. So Pythagoras theorem is that the base square plus perpendicular square is equals to hypotenuse square. Now we are going to put the values here only. So the base is, if we are taking a triangle, so the base is a square, that is BC. BC square is equals to perpendicular, that is an AD, is equals to hypotenuse, that is simply A by 2, that is AB square is equals to AD square plus DB square. You are taking a triangle ADB. So AB square is equals to A square is equals to AD square, that is not given, you have to find this only, plus DB square, that is A by 2 whole square. Then AD square is equals to A square minus A square by 2, that is A square by 2. Then we got, what we have got? This one is becoming 4, then it become 3A square upon 4 AD square. When it become AD, then under root 3A upon 4 upon 2 upon 2. So the height of the triangle, height of a triangle is equals to root 3 by 2A. Here we got the actual formula of direct finding the height of the equilateral triangle. So what you have learned here? You have learned that the area of a triangle, that is an equilateral, is root 3 by 4 a square. If we are going to find the height, that is root 3 by 2a. I hope you understand. Now we have to read about the area of a quadrilateral. Quadrilateral is also a type in which two more triangles are included. So now what is an area of quadrilateral? First of all, we have to draw a diagram here. So diagram is now we have to name it A, D, A, B, as well as a diagonal is given. Their height also. These are the height, that is H2, H1. These are the perpendicular sides. Now this is M, this is L. So what is the area of quadrilateral? First of all, you have to know what is quadrilateral. So quadrilateral whose one diagonal and lengths of perpendicular from opposite vertices to the diagonal are given. So the formula, when we are going to find the formula, so the area of a quadrilateral is equals to half AC, means a diagonal, into H1 plus H2, means half diagonal, half D, that is diagonal, into sum of perpendicular height. You got the formula? That is half D into sum of heights. Now after that, now let us practice some questions related to that Heron's formula. First question is that question 1, that is find the area of a triangle, find the area of a triangle whose base is 25 centimeter long and the corresponding height is 10.8 centimeter. So the solution is, first of all you have to write what is given here. So given is base of a triangle, that is 25 centimeter, and corresponding height that is 10.8 centimeter. So now solution. which formula you have to use? You have to use that formula in which base and height is given. Then you have to use not a Heron's formula but a half base into height. So the formula used is half into base into height. So half, which base is given? 25 centimeter into height 10.8. Then you have to cross this 5,4. After that 5.4 into 25. So the answer is 135 centimeter square. That is the area of the triangle whose base and height are given. Another question. There is another question. Find the area of a triangle two sides of which are 8 centimeter and 11 centimeter, and the perimeter is 32 centimeter. So what we have to find the area of a triangle. Here you have to, there is no triangle is given, which type of triangle is there, only the sides are given, and for the sides which formula we have derived, that is Heron's formula. Okay, now first of all you have to find the third side. There are two sides are given. Two sides are, that is 8 centimeter and 11 centimeter. So third side is perimeter is given also, is equals to which side? 32 centimeter. Perimeter is the sum of all the three sides of a triangle, is equals to A plus B plus C. You have to find third side, also perimeter is given. So 32 is equals to 8 plus 11 plus C, that is 32 minus 18 is equals to C, means 4, 1, 14 centimeter C, means third side is of 14 centimeter. Now you have to got all the three sides, that is 8, 11 and 14. Now you have to use Heron's formula. First, S is equals to A plus B plus C by 2 is equals to 8 plus 11 plus 14 by 2. Sorry, that is 8, 9, 13, 1, 3, 33 by 2. Now what you have to use Heron's formula. So the area of a triangle under root S minus A, S minus B and S minus C is equals to under root S, that is 33 by 2, 33 by 2 minus 8, 33 by 2 minus 11 and 33 by 2 minus 14. So under root 33 by 2, and you have to first will have to solve 1 by 1 bracket, or if you want to solve, then solve in a 1 second only, means you have to solve these brackets in a 1 type only. So you have to take LCM. So 33 minus 16 by 2, 33 minus 22 by 2 and 33 minus 28 by 2. After that, under root 33 by 2 bracket, when we subtract 33 from 16, what you have get? You have get 70. Is it true? Okay. Now 11 by 2 and 5 by 2. Now you have to take common out of it because it of square root. So what you have get? You have got 2 outside and only 11 outside. After that, what you have got? 3 into 17 into 5 on under. This is your answer of the area of a triangle by using the Heron's formula. Have you got it? After that, there is another question. That is the length of the sides of a triangle. The length of a sides of a triangle are in the ratio (3 is to 4 is to 5). Its perimeter is, means a perimeter is given as well as the ratio of the sides are given, means not the actual side but only the ratio of them. So by using ratio you can able to find the actual sides. So perimeter is 144 centimeter. Find the height. Find the height. So first of all, what is given? It is given a perimeter. So the perimeter is 144. If we let the sides are, let the sides be 3x, 4x, 5x. So these all sum is equals to what? Perimeter. So let us do 3x plus 4x plus 5x is equals to 144, and 4, 3, 7, 5, 12x is equals to 144, and what we have get? We get the value of x as 12. Now put these 12 on the all the three. The sides are now 36, 48, 60 centimeter. These are the sides of a triangle. Now you have to find the height. First you have to find the what? First you have to find the area. So the height of this triangle is actually, this is an right angle triangle. Which triangle it is? Right angle triangle. Why? Because it satisfies the Pythagoras theorem. Which theorem? Pythagoras theorem. So the 36, 48 and 60, because this is a right angle triangle. So you have to find the corresponding height. This height you have to find. So first type you have to solve this type only. The first form you have to solve half base, that is 36 into 48 is equals to another base. If we have taken 60 as a base and height is at h, then you have to solve this. .6 is the height of the corresponding height of the corresponding to the longest side or what? Hypotenuse. So have you got it? Now there is another question related to equilateral triangle, that is question height of the equilateral triangle. Height of the equilateral triangle is 6 centimeter. Find area. So for area first you have to find the side by using the height of the triangle. So height is equals to, we have already derived this formula, that is √3 by 2a. So root 3 by 2a is equals to 6 centimeter. So a is equals to 12 by root 3. Now you have to use area of equilateral triangle is equals to root 3 by 4 a square. So now you have to put the value of a here only, that is 12 by root 3 into 12 by root 3. Now 4 3s are 12, 3 se 3 cut, root 3. So the answer is 12 root 3. This is the centimeter square answer. And what is the answer? Answer shows you the area of equilateral triangle. Now there is another question related to isosceles triangle. Question is, area of a isosceles triangle whose equal side whose equal sides are 13 centimeter and whose base is 24. Isosceles triangle is that triangle whose two sides are equal. As you have learned, equilateral triangle is a triangle whose three sides are equal. In the same way, isosceles triangle is a triangle whose only two sides are equal. So sides of it are 13 centimeter into 24. Now you have to use which formula here? Heron's formula. You have to use Heron's formula. So first you have to find S, that is 13 plus 24 by 2, that is 26 plus 24 by 2, that is 50 by 2, 25. Now formula is under root S minus A, S minus B and S minus C, under root 25 minus 13, 25 minus 13 and 25 minus 24, under root 25 into 5, 7, 5, 12 into 12 into 1. So the 5 into 12, 60 is the answer. Centimeter square. 60 centimeter square is the answer of this question. So here we have completed our which chapter? Our 10th chapter, that is Heron's formula, which clearly tell you about the history of the Herons as well as how the formula derives, as well as the different types of finding the area of a triangle by different formula. Like, now we are going to revise whole the topic which you have studied here only, that is first, what is Heron's formula? So Heron's formula is a formula used to find the area of a triangle when all the sides are different. In the same way, we are using the perimeter as well as a semi-perimeter. Semi-perimeter is the half of the actual perimeter. Perimeter is the sum of all the sides. So semi-perimeter is the half of the perimeter. After that, you have learned the formula, that is under root S minus A, S minus B and S minus C. Now second formula is when the base and the height of a triangle is given, then you have to use the formula of the area of a triangle is equals to half base into height. Now next formula is which formula? The area of the equilateral triangle, in which we have learned what is an equilateral triangle. So the equilateral triangle is actually a triangle whose sides as well as the angles are all equal. Now the formula of the area of equilateral triangle is root 3 by 4 a square. After that, we have doing some the questions as well as we have also learned about the quadrilateral whose formula are half into diagonal and the corresponding height sum of the corresponding height into diagonal whole or half. So we are doing some questions also, ratio in this question we have learned a new triangle, that is an isosceles triangle. In this triangle, the two sides are given as well as the one side is different. In the same way, the two angles are equal and one angle is different. So we have learned the different formulas as well as the different types of triangles. So thank you so much for this class. Let's meet you soon in our second class of this chapter, that is summary class. Thank you so much.